Okay, in this video we're going to discuss verifying trig identities. Okay, and I'm going to give you a few examples, but the bottom line is you have to go practice a lot of them. All right, so here's some things to keep in mind before we get started. All right, so we need to learn fundamental identities. These are like the reciprocal identities, the Pythagorean identities. There'll be some new ones coming up, like the sum and difference identities or the double angle identities. So anyway, there'll be some fundamental ones that we just have to know. Right? They will make things run a little smoother if we know them off the top of our head. We're going to have an equation, and we're going to want to verify that the equation is true. And what that means is we're going to have two sides of the equation, and we're going to be able to take one side and rewrite it so that it looks like the other side. That's the plan, right? And so with that in mind, try to rewrite the more complicated side of the equation so that it becomes identical to the simpler side. Now sometimes one side's not more complicated than the other. Right? Sometimes it's obvious, sometimes it's not so obvious. But just kind of keep that one in mind. We're going to try to work with the more complicated side. Number three, though, is you got to try something. You can't just sit there and look at the situation and go, well, I don't have a clue what we're going to do. You have to try something. It may be helpful to express all the functions in the equation in terms of the sine and cosine function. Just change everything to sine and cosine and see if that doesn't help. Right? There may be times when you'll need to factor an expression, possibly add rational expressions, or maybe even use the conjugate of an expression. Everybody remember the word conjugate? If not, you need to go look that up. All right. Keep in mind, there's going to be two sides to the equation, right? But we're verifying that the equation is true. We're not solving anything, right? So our goal is to take one side and make it look like the other side using a bunch of trig identities. Okay. So one side we will not be changing. That's going to represent our goal. Right? So here we go. Here's our first example. We want to verify that the tangent of theta plus the cotangent of theta is equal to secant theta cosecant theta. All right, well, looking at it right away, it looks kind of spooky, right? But say we change everything to sines and cosines. Like tangent theta is sine theta divided by cosine theta. And you must have the thetas in there, right? If you just write sin and cos, that's not correct. Okay. All right, then plus cotangent theta we can change to cosine theta over sine theta. Okay, we're going to leave the right side alone. Okay, we're going to mess with the tangent and cotangent. All right, so what good does that do for us? Well, we're adding two fractions here, right? So how do you add fractions? Well, you get a common denominator. What's the common denominator? Cosine theta times sine theta. So to add these two fractions, we need to multiply the top and bottom of this first fraction by sine theta and the top and bottom of the second fraction by cosine theta. When we do that, we get sine squared theta over sine theta cosine theta plus cosine squared theta over sine theta cosine theta. Then we have the same denominator. So we can say, all right, sine squared theta plus cosine squared theta all over sine theta cosine theta. All right, and what's sine squared theta plus cosine squared theta? That's right, that's 1 over sine theta times cosine theta. Then move up a bit here. Then that's the same thing as 1 over sine theta times 1 over cosine theta. And 1 over sine theta is cosecant theta. And 1 over cosine is secant theta. And that does indeed equal your right side now, right? We're done. You just verified it. Our goal is to take one side of the equation, use trig identities and some algebra to make it look like the other side. That's our entire goal. Once we do that, we say, well, this is a true statement. Then this thing up here is a true statement. One reason why this would be important would be, say, in calculus, it might be easier to do the calculus if your expression was in a different form as opposed to the original form that you have it. So if you can take the original form and rewrite it a different way into maybe a simpler situation, it would be easier to do the calculus on it. So that'd be like the applications of that you'll see possibly down the road in calculus. Right now, we are just practicing our identities. All right, here's the second one. All right, so on this one, the more complicated side would be the left side, right? So we're going to see if we can turn this left side into sine squared x. All right, there's several ways we could go about it, but one thing I want you to see is that everybody agree we could rewrite this as two fractions subtracted together, right? We could rewrite this as secant squared x over secant squared x minus 1 over secant squared x. Well, secant squared x over secant squared x is just 1, right? And 1 over secant squared x is cosine squared x, right? And then 1 minus cosine squared x, is that special? Yeah, since sine squared plus cosine squared equals 1, then 1 minus cosine squared has to equal sine squared x. And you've just verified that identity. Okay? So just another thing you kind of look for. All right, one more thing I want to show you, and then you just have to go practice a whole bunch of them. All right, so I'm going to work on the left side here. The reason why is I want to show you a technique that's used from time to time, so you'll be aware of it. We're going to take this left side and see this 1 minus sine x. We don't really like the 1 minus sine x. It would be cool if it was 1 minus sine squared x, right? Because then that would be a cosine squared situation. So to get that, we need to multiply the top and bottom of this fraction here by the conjugate of the denominator. Okay, sometimes it'll be the conjugate of the denominator. Sometimes you might need to multiply the top and bottom by the conjugate of the numerator, right? In this case, it's the conjugate of the denominator. So 1 plus sine x. So the numerator is going to go to, just distribute that through, you'd have cosine x plus cosine x sine x. And the denominator is going to go to 1 minus sine x times 1 plus sine x. Remember, they're conjugates of each other. So that's going to go to 1 minus, you got sine x, negative sine x, they cancel out. And so then 1 minus sine squared x. Everybody with me so far? I'm going to scroll up just a little bit. All right, so then we have cosine x plus cosine x sine x still on the top, but the denominator now goes to cosine squared x, because 1 minus sine squared is cosine squared. And then, remember, let's keep in mind what our goal here is. Secant x plus tangent x. I'm going to scroll up. All right, so now let's write this as two separate fractions, right? So we would have cosine x over cosine squared x plus cosine x sine x over cosine squared x. And everybody see what's going to happen? This is going to go to 1 over cosine x. This is going to go to sine x over cosine x. And 1 over cosine x is secant x. Yes, you need to put this last line in. And sine x over cosine x is tangent x. And that does indeed equal what we have on the right side. The end. All right, so the goal is to take one side of the equation, right or the left, doesn't really matter, and turn it into the other side of the equation, right? And we don't multiply both sides of the equation by something. We don't add or subtract both sides of the equation by something. You're literally just taking one side of the equation and doing some algebra on it with some trig identities to make it look exactly like the other side of the equation. Okay? All right, watching me isn't going to cut it. You need to go practice many, many, many of them. All right, study well. Please let me know if you have any questions.